Hello everyone. Welcome to this topic of coordinate geometry. So before we start with the topic, let's see what are coordinates. Okay. So this is y-axis and this is my x-axis. Correct? This point is nothing but as 0, 0. This is 1, this is plus 2, this is plus 3 and so on. This is minus 1, that's minus 2, minus 3 and so on. Similarly, on y-axis we have plus 1, plus 2, plus 3 and so on. And here on the negative y-axis we have minus 1, minus 2, minus 3 and so on. So for example, if I say this point, the x coordinate is 1 and y coordinate is 0. So this point is nothing but as 1, 0. Correct? Now if I have to check which is this point. So this point, it is pointing, x coordinate is minus 2 and y coordinate is plus 2. Similarly, can anyone tell me what will this coordinate be? Yes? So the x-axis is pointing to 1 and y-axis is minus 3. So this coordinate is 1, minus 3. Okay. So these are basically coordinates and we are going to do coordinate geometry in this topic. So basically in this topic we will be looking at how to find the area of a triangle or a centroid, or how to draw a straight line on x and y axis, how to draw a circle, and so whatever you have done in your geometry, we are going to do this using the coordinates. Now before we move ahead, it's very important to know that x-axis is sometimes also called as abscissa. I mean, it's better you know this because an examiner can very well give you that the abscissa of this line is this. Okay, so if you don't know what is abscissa, you will not be able to solve the question, right? Great. So let's move ahead. Now, so let us start with a very basic concept. So between this 2 points, so let's say this point is x1, y1, and this point is x2, y2. If I want to find the distance of this 2 points, okay, and let the distance be denoted by d. So this distance d is given by under root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay. Now this is no rocket science here. Okay, this is nothing but an application of Pythagoras theorem. If you just extend this point, this is nothing but as your x2 and x1. So x2 minus x1, and this is y2 and this is y1. So this is y2 minus y1. Correct? So apply Pythagoras theorem here. This is an hypotenuse, and you get this. Great. Okay. So you can have various questions on application of this. I mean, there can be a straight away question, find the distance between these 2 points, but that's very rare to ask, considering the level of the difficulty of the aptitude exam that you are going to give. Probably they would not definitely ask questions straight away, find the distance, and hence to check what kind of question that they can ask is, so come to coordinate geometry, higher mathematics book, That's the first chapter of your book, and I would want you to come to page 7. On page 7, question number 5 and 6 are good application of coordinate geometry. I mean, the distance formula. Okay. So, what I would want you to do is, I would want you to solve question number 5, solve example 5. I'm giving you 3 minutes time, and let's see how many of you can solve this question. So, please. Okay. Let's see how many of you got it correct. Now, what we are supposed to do here is, what is the type of quadrilateral formed by this point? So, if you have done your geometry properly, then quadrilateral can be bifurcated, can be segregated as, you can have rhombus, you have rectangle, or you have square, correct? Or you can have a kite as well. I mean, any four-sided figure. It could be any general quadrilateral as well. But now here, let us see what are the properties of rhombus. So in rhombus, all the four sides should be equal, right? And angles are not at 90 degree. But can I also say there's one more property which segregate the rhombus with square is that the diagonals of rhombus are not equal and that of squares are equal. How about rectangle? In rectangle, the opposite two sides should be equal and the other two opposite sides. So basically, AB should be equal to CD and BC should be equal to AD. If that happens, then it is possibly a rectangle or it can be a normal parallelogram. Now, how to identify whether it's a rectangle or parallelogram? You find the length of the diagonal. If the diagonals are equal, then it's a rectangle. If they are not equal, then it's a parallelogram. If two sides, if AB is equal to AD, okay, and BC is equal to CD, which means the two adjacent sides are equal. Okay, if two adjacent sides are equal, then it would be a kite, provided the diagonals are intersecting at 90 degree. So diagonals are intersecting at 90 degree. Probably we'll do this when we do the angles between two lines. But as of now, what we can do is just try and find out what are the lengths here. So if I have to find what is AB, so what will be AB? So that will be 4 minus 1, that is 3 square, which is 9, plus 2 minus 7, that is minus 5 square, which is 25. So square root of 9 plus 25 is square root of 34. Right? Now similarly, if you try to find out BC, you get minus 1 minus 4, that is minus 5 square is 25, and minus 1 minus 2 is minus 3 square is 9, which is again root 34. Correct? Now let's find what is CD. So that's minus 4 minus of minus 1 is minus 3 square is 9. Then we have 4 minus of minus 1 is 5 square is 25. So that is again root 34. Then lastly, we find out what is DA. So it would be 1 minus of minus 4, that is 5 square, which is 25. Then we have 7 minus 4, which is 3. 3 square is 9, and again we have root 34, which means all four sides of quadrilateral are equal, which means it can be either a rhombus or it can be a square. Now, to eliminate either of them, what will we do is we will find out what the length of AC and the length of BD, right? So length of AC would be nothing but as minus 1 minus 1, that's minus 2 square, that's 4, and minus 1 minus 7, that's minus 8 square is 64. So AC is nothing but as root of 68. And similarly, let's find out BD. So BD is nothing but as minus 4, that's minus 8 square, which is again 64. And 4 minus 2 is nothing but as 2, that's 2 square is 4. So what we get here is root 68. So I can see that the diagonal lengths are also equal, which means this quadrilateral is a square. Clear, everyone? Great. Let's move ahead with another concept, which is sectional formula. Now, let's take a point A comma B. Let's take A, x1 comma y1. Let's have this point here, and let's have the point B, which is x2 comma y2. Let us say that this 2 points are internally divided by a point P, which is x comma y, and it divides AB in the ratio m is to n. It's divided AB in the ratio m is to n. So if I want to find out the x coordinate of P and the y coordinate of P, what should I be doing? So I'll multiply m. Remember, this distance m of P is from A. Okay, but we'll multiply m by the coordinates of B. So it is mx2 plus, similarly n will get multiplied by the coordinates of A. So it is mx1 upon m plus n. And the y coordinates of P would be nothing but as ny2 plus ny1 upon m plus n. So these are the x and y coordinates of P. Great. Now, what if this point P is exactly a midpoint? In that case, what will be this ratio? The ratio would be 1:1. Correct? If this ratio becomes 1:1, in that case, the x coordinate of P, this is 1 and this is 1, right? So this will be x2 plus x1 upon 1 plus 1, that's 2. So it is x2 plus x1 upon 2, and the y coordinate would be y2 plus y1 upon 2. So if P is the midpoint of the two, of the line, and if you know the coordinates, the extreme coordinates, you can straight away find the midpoint. That's nothing but as the formula for average, right? So addition of two numbers divided by Great. Now let us see what if this point is outside the line. So basically, this is an internal section formula. Okay. If the point P is outside the line AB, then in that case it would be called as an external sectional formula. Okay. Let's say the point A is x1, y1, and point B is x2, y2. If point P, x comma y, divides AB externally in the ratio m is to n, then what are the coordinates of x comma y? What are the x comma y? So the same thing. Distance of P from A is m, but we'll multiply m by coordinates of B. And similarly, distance of P from B is n, but we'll multiply n with the coordinates of A. So it is mx2. Now in this case, instead of plus, it is minus nx1 upon m minus n, and the y coordinate would be my2 minus ny1 upon m minus n. So this is the formula for external sectional division. Now what I would want you is, I would want you guys to apply this formula in question number 4, solve example 4, that's on page number 6. It's little tricky, but let's see if you are able to get this correct. So I am giving you 2 more minutes to solve this. After 1 hour, at least minimum 1 hour. Okay, so let's see how to solve this question. It says find the coordinates of the points of trisection, points dividing in three equal parts. So let us say this is point P and this is point Q, right? Uh, and it's joining the point A comma B, that's already done. So we need to find the coordinates of basically P and Q. Now, basically this is 1 is to 1 is to 1. Correct? So, if I consider point P here, can I say P divides AB in the ratio 1 is to 2, right? So my M is 1 and my N is 2, right? So this is 1 and this is 2. So if I want to find out the x coordinate of P, so it is 1 into minus 8, which is minus 8, plus 2 into 3, that is 6, upon 1 plus 2, that is 3. So this will give us minus 2 by 3. Correct? Similarly, the y coordinates of P would be 1 into 12, that is 12, plus 2 into minus 4, that is minus 8, upon 1 plus 2, which is 3, and this is nothing but as 4 by 3. So now we know that this point P has coordinate minus 2 by 3, comma 4 by 3. Now what we can do is we can apply the section formula for the point Q such that this is 2 and this is 1. That's one thing. The another thing that what we can do is, now I know that Q is the midpoint of E and B. So let us apply the midpoint formula because that's relatively easy, correct? So if I have to find out what are the coordinates of Q, okay, so it is minus 2 by 3 minus 8 divided by 2. So if I say x coordinate of Q is minus 2 by 3 minus 8 divided by 2. So that is minus 24 minus 2 is minus 26, minus 26 divided by 3 divided by 2. So this will be nothing but as minus 13 by 3. So the x coordinate is minus 13 by 3. And now let us find out what's the y coordinate. So the y coordinate would be 4 by 3 plus 12. 4 by 3 plus 12 upon 2. So that is 36 plus 440. 40 divided by 3 divided by 2. So that is nothing but as 20 by 3. So the y coordinate will be nothing but as 20 by 3. You could have used intersection formula, but I guess this would be little faster. You just need to simply add the value, right? Yeah. So this was an application of section formula. Now I will just give you one more question on section formula. It's a little bit tricky question. Let's see if you are able to guess correctly. Let's say there is a point A which is minus 3 comma 4. There is a point B which is 2 comma 5, and for P it is x comma y. And now it says that this distance is 3 and this distance is 2, and you have to find the x coordinate of P, x and y coordinate of P. So there are two things that you can do. One, you can use internal section formula. B is dividing AP in the ratio 3:2, and you will get kind of cross multiply for solve an equation, and you still get it. But somehow, if you want to apply external sectional formula, in that case, you have to be careful. You have taken the distance as 5 and not 3. So your M will be 5 and your N is 2. Okay, many a time while student using external section formula, they take m as 3 and n as 2, and that's a mistake. You have to always remember that the distance are always measured with respect to the point that you want to find out, the coordinates of the point that you want to find out. So distance of A from P is 5 and that of B from P is 2 and not 3 and 2, it's 5 and 2. Okay, so I'm sure after this you'll be able to solve it, right? Great. Let's move ahead. How to find area of a triangle and area of a quadrilateral. So let's say this is a triangle with point x1, y1, B is x2, y2, and C is x3, y3. If I want to find the area of the triangle, so I mean we know that area can be found by determinant. On solving determinant, what you get is it is half of modulus. So you write x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y3 and modulus x. So basically, how to remember? So I've written x1, x2 and x3 outside. When I've written 1 here, the y follows is 2, 3. So it's 1, 2, 3. I'm writing 2. After 2 I get 3 and then 3 I get 1. So it's a cycle repeat. After 3 I get 1 and after 1 I get 2. So it is y1 minus y2. So this is the formula for finding area of a triangle if the coordinates are known to you. Great. Now, what if I ask you to find out area of a quadrilateral? So let us draw a quadrilateral. Let's say this is A x1 y1, B x2 y2, C x3 y3, and D is x4 y4. Now in this case, there are two ways. One, divide the quadrilateral into two triangles. Find the area of this triangle and area of this triangle. You add them, you still get the area of quadrilateral. That's one way to solve it, right? The another way, that's another formula. So let's go in a cyclic order, this order. Okay. So the area would be given as half modulus of. If I am taking this 2 point, okay, if I am taking this 2 point, so x1 y2 minus x2 y1 plus, and let's take this 2 point, x2 y3 minus x3 y2 plus, now let's take this 3 point, this 2 point, so it is x3 by 4 minus x4 y3. Now let's take this 2 point, so it is x4 y1 minus x1 y4. Now you have to be careful the order in which you are going. If you have taken this 2 point, it's x1 y2 first and then x2 y1. If you have taken this 2 point, now if you do x3 y2 first and then if you do x2 y3, you may, because this will reverse, this comes out to be negative, right? So the answer may vary. So you have to be very careful. And if you're not sure about it, it's better to apply area of a triangle twice and get the answer. Okay, so now on the basis of the area, what I would want you to is, I would want you to solve the question. Come to page number 6, and I would want you to solve example 2 and 3. I am giving you 3 minutes to solve these two questions first. Okay, let's solve the first question. Let me help you with the first question. So we want to find the area of a triangle which is formed by 3 points is given by half of mod. So let us first write down. So this is my x1 y1. So this is x1 y1. This is x2 y2, and this is x3 y3. So it is x1, that's minus 2. It is y2 minus y3. So that's 5 minus 9 plus x2, that is 4. So now this will be y3 minus y1. So that is 9 minus 3. And then we have 7. So that's x3 is 7, and we have here y1 minus y2. So that is 3 minus 5. Okay. So now let's simplify this. So 5 minus 9 is minus 4, and minus 4 into minus 2 is plus 8. 9 minus 3 is 6. 6 4s are 24. And 3 minus 5 is minus 2. 7 into minus 2 is minus 14. So 24 minus 14 is 10. 10 plus 8 is 18, and half of 18 is 9. So that's the answer. That's the area of a triangle. Correct? Great. Now, what we can also understand, let me ask you the another question on the similar points. So that's the same question, the third question. So if the 3 points are given to you and you have to find out whether these 3 points are collinear or not. Okay. Why do we find area of a triangle? Because let's say if these 3 points were collinear, A, B and C. In this case, the area of triangle would turn out to be 0. So by chance, if the area of triangle turn out to be 0, then the 3 points are collinear. If it is not 0, even if it is 0.1 or it is 0.2, 0.05, then a triangle exists. And that's what the third question is all about. You have to check whether the 3 points are collinear or not. Okay. Now, there is one more method by which you can find out whether the points are collinear or not. That's when we do the slope of a line. I will again take this question and we'll solve this question by the help of slope. Great. So let's move ahead. Let's see how can you find centroid and then in center of a triangle using the coordinates. So let's take this triangle A x1 y1, B x2 y2, C x3 y3. Okay. So if I want to find the centroid, okay, let us say it is G x comma y. So the x coordinate of centroid is nothing but as x1 plus x2 plus x3 upon 3. It's basically the average of all the x coordinate. And the y coordinate of centroid will be y1 plus y2 plus y3 1 upon 3. Right? So for 2 points, the midpoint was the average. Centroid, when there are 3 points, the average of 3 points. Right? Now, let us find out the, let's say this is a point I. Let's say this is a point I. In center is x comma y. Okay. So if I want to find out the x and y coordinate of in center. Now, before that, always remember the length opposite to angle A is always denoted by small a. It's always denoted by small a. Length opposite to vertex B, angle B, is always denoted by small b, and the length denoted by opposite to the angle C is denoted as small c. Right? So the x coordinate would be, you will multiply ax1, then it is bx2, then it is cx3 upon a plus b plus c. And similarly, if you want to find out the y coordinates, the y coordinate will be ay1 plus by2 plus cy3 upon a plus b plus c. So these are the x and y coordinate of centroid, and these are the x and y coordinates of in center. Clear with this, everyone? Okay. I would want you to take down this in the book. This formula is already given. This is given on page number For page number 2, centroid is already given. Okay, just on the side, maybe you can note down this formula as well, the formula for in center. Okay, let's move ahead. So now, ax plus by plus c is equal to 0. What is this? This is nothing but as the general equation of a straight line. It's the general equation of a straight line. Here, the slope of a line is nothing but as minus of x coordinate upon the y coordinates. Not the coordinate, the coefficient. Minus of x coefficient upon y coefficient. Okay. Now, let us understand what is slope. So, let's say if this is a line ax plus by plus c is equal to 0. The angle made by this line from positive x-axis, let's say this angle is theta. The slope of this line is denoted by m. Will also be given as tan theta. So if I simply know the angle, so let's say the angle is 60 degree. So what is tan 60? Yes, tan 60 is root 3. Correct? So the slope of this line would be root 3. Great. Now, let's say I have a coordinate here x2, y2, and if I have a coordinate here x1, y1. So a line is passing through 2 points x2, y2 and x1, y1, and I still want to find the slope of a line. In that case, how can I find out? What I will do is I will simply rub this right as of now. And I'll enlarge this figure to help you understand better. This is x2, y2, and this is x1, y2. So if I want to find the slope, what did we say? The slope is nothing but as tan theta. But you would say that I mentioned with respect to positive x-axis. You can see here, if this angle is theta, this angle would also be theta because these two lines are parallel and these two angles are equal with corresponding angle dashed. Right? So if this is theta, this also is theta. So if I find out tan theta, what is tan theta? How do you find tan theta? It is opposite upon adjacent. That is nothing but as y2 minus y1 upon x2 minus x1. You can also write y1 minus y2 upon x1 minus x2. That's fine. But if you write y1 and y2, it should be x1 and x2. So you need to follow the pattern. Right? Fine. So I am sure you have understood what is the slope of a line, how to find the slope of a line. So one, if the angle is known to you, you can straight away find tan theta as slope. The angle is not known to you, and if it is known to you that it is passing through two points that are these 2 points, you can find the slope by this, right? Great. And I'll repeat again, if it was ax plus by plus c is equal to 0, then the slope as discussed earlier was minus a by b. Clear everyone? Okay. What I would expect is, what I would want you to do is simply write down this thing, ax plus by plus c is equal to the slope is minus a by b. On page number 3, the first h straight line where ax plus by plus c is written, write down slope is equal to minus a by b. Great. So let's move ahead. Let's move ahead with finding the equation of a line. Okay. Now let's say the slope of this line is m and it is cutting y-axis at point C. So this distance is also C. Great. In that case, equation of a line is nothing but as y is equal to mx plus c, and this is what we have been learning in our schools, right? Y is equal to mx plus c. So basically this is called as slope intercept form. This is y-intercept. So what would be this in that case? If this is y-intercept, this would be x-intercept, because this is the distance of point where the line is cutting x-axis from the origin. Clear, everyone? Great. Now, let's see how can you find an equation of a line if 2 points are given, x1, y1 and x2, y2. So, it's basically, we will write down y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus, I have written y1 here, so I will write down x1. If I would have written y2 here, I would have written x2. The same thing, the pattern should follow. Great. So this is basically the equation of a line if 2 points are known to you. Now, what if only one of the point is known to you? Let's say the point known to you is x1, y1, and you know the slope of this line is m. So it's given that a line is passing through the point x1, y1 with a slope m. Now, if you closely observe, this is nothing but a slope of a line, right? So the equation would be y minus y1 is equal to m x minus x1. It's the same thing, there is no difference. It's simply that this is replaced by a slope, that is m. Clear, everyone? Great. Let us see the next form of a line. So now, let's say it is cutting x-axis at point A and it is cutting y-axis at point B. So, what I mean the equation of this line, you will divide x by A plus y by B and you will equate this to 1. So x by A plus y by B is equal to 1. This is called as double intercept form. So after doing various forms of line, framing the equation of a line, what we'll do is now let us try and apply. Let me give you some examples so that it will become easier for you to relate. Now let us take a random example. Let me say that it is cutting the x-intercept is minus 2 and y-intercept is 3. So if I want to find out the equation of a line, what should I do? X upon minus 2, that's x-intercept, plus y upon 3, that is equal to 1. So if you simplify this, what will you get? 3x, minus 2y minus 6. So minus 6 comes on this side and this is equal to 0. Right? Now, let's say this line is given to you. And if I ask you to find out the slope of a line. So what is slope of a line? So it is minus of x coordinate, that is 3, upon, not x coordinate, minus of x coefficient, that is minus of 3, upon the coefficient of y, that is minus 2. The slope here is 3 by 2, that is 1.5. Now, what if this equation is given to you and they ask you to find out the y-intercept? So how will you find the y-intercept? One way is that you do it like this. I mean, you frame this equation in this way and you get y-intercept. That's 3. What is other way? Just by looking at this equation, can you find out the y-intercept? Okay, so let me take you to, let us simplify this first. Okay, so what I'll do is, I'll write this equation in terms of y is equal to mx plus c. So, if I take 2y here, I'll have 2y is equal to 3x plus 6. Right? Now if I divide this by 2, what will I get? Y is equal to 3 by 2 of x plus 6 by 2, which is 3. And if you see, when y is equal to mx form, and is your slope, that is what we got here. Right? And this is my c, that is y-intercept, that is what we had here. Right? So if x and y intercept are given, you will use this and get the equation of a line. If the equation of line is given, the slope can be directly formed by minus of coefficient of a upon b, upon minus of coefficient of x upon the coefficient of y. And if they are asking you to find the slope, so this is one. If they are asking you to find y-intercept, now maybe you can do this, or what you can say is, it is constant term upon the minus of coefficient of 5, that's 6, upon minus of minus 2, that's 2, 6 by 2 is nothing but as 3. Clear, everyone? Great. So let's take another example. Let's take, okay, before that maybe you can take this down. Maybe you can take this down. I'm giving you a minute or so, and then we move ahead with taking few more examples. Okay, let's move ahead. So let us say the points that they have given is minus 2 comma 3 and 1 comma 2. These are the 2 points that they have given, and they are asking you to find out the equation of a line. So by the way, what would be the slope of the line here? Let us first find the slope of a line. The slope of a line m is y2 minus y1, so that is 2 minus 3 upon 1 minus of minus 2, that becomes plus 3, so this is minus 1 upon 3 is the slope. Right? Now let us try to find out the equation of a line without using the slope. Let us use this 2 point and see, are we getting the same slope? I mean, we should be getting it if we don't make a mistake, right? So let's use the formula that we have given. So it is y minus 3 is equal to, I'll say 2 minus 3 upon 1 minus of minus 2 into x minus. So I had taken this y here, so I'll take this x. That becomes minus of minus 2, that becomes plus 2. Right? So this will be y minus 3 is equal to minus 1 by 3 of x plus 2. Let's take 3 here. So this will be 3y minus 9 is equal to minus x minus 2. If I take everything on one side, I'll get x plus 3y. That's minus 2 minus 9 plus 2 minus 7 is equal to 0. So from this equation, how will we find the slope of a line? Minus of coefficient of x, that is minus 1, upon coefficient of y, that's 3, that's minus 1 by 3, and that is what we have got here. Now what would be the y-intercept here? Yes? So it would be minus 7 upon minus 3, that is 7 by 3 would be the y-intercept. Clear everyone? Great. Now let us see few more standard basic lines here. Okay. So this is y-axis and this is x-axis. Right? Y-axis is nothing but s, x is equal to 0. Right? And x-axis is nothing but s, y is equal to 0. Right? So if I say the line is parallel to x-axis and it is passing through 3, this was y is equal to 0, this becomes y is equal to 3. Right? And if I say that this line is passing through, let's say, minus 7, so it is passing from x is equal to minus 7, so this is x is equal to minus 7. So if a line is parallel to y-axis, it will be x is equal to something. And if a line is parallel to x-axis, it is y is equal to something. I'll repeat. A line is parallel to y-axis, it is x is equal to something. And if a line is parallel to x-axis, it is y is equal to something. Right? Now, let's say there are two lines which are parallel and the slopes are m1 and m2. In this case, their slopes will be equal. m1 will be equal to m2. If the lines are perpendicular, the slope of this line is m1 and that of this line is m2. Okay. Now here, if the lines are perpendicular, in this case, the product of the slope is minus 1. Or you can say the slope of one line is negative reciprocal of the second line. Correct? Great. So the lines are parallel, it's m1 is equal to m2. And if lines are perpendicular, the product of the slope is minus 1. Now, what if the two lines are intersecting at an angle theta? This line has slope m1 and this line has slope m2. So, if you want to find tan theta, then in that case, it is given as m1 minus m2 upon 1 plus m1 m2. Okay. Now, if you closely observe this, you would realize that if the lines are parallel, m1 is equal to m2, this becomes 0. If tan theta is 0, so theta is 0. Right? And if the lines are perpendicular, this is equal to minus 1, so denominator becomes 0. In this case, this is not defined. So when is tan theta not defined? When the theta is 90 degree. So the previous example, the previous rule have been derived from this and from nothing else. Great? Wonderful. So let's move ahead now. Okay. So now what I would want you to do is, let us solve some questions. Let us see if you are able to apply from the book. So come to page number 7, everyone. I would want you to solve example 8. And then I would want you to solve example number 10. Solve question example 8 and example 10. I'm giving you 2 minutes. These are relatively very easy questions. Fast. Great. I'm sure you would have solved it now. So the 8th question says, find the equation of a line which makes an angle of 60 degree with x-axis and passes through root 3 comma 3. Now you would wonder that I have not given you any formula when the angle is given. But then we know that if a line is making an angle of 60 degree, then the slope of this line is nothing but as tan 60 and this is root 3. Right? So now we know the slope, that is m, and we know one point, that is root 3 minus 3. So let us use slope point form. So it is passing through root 3 comma 3. So it is y minus 3 is equal to y minus y1 is equal to n x minus x1. Correct? And then we solve this, what do we get? So it is y minus 3 is equal to root 3x minus 3, which means this gets cancelled out. So I'll get root 3x minus y is equal to 0, or I can say y is equal to root 3x. I mean, whatever options are given to us. Clear, everyone? Okay. Now, what does this mean? Can you tell me when y is equal to root 3x is there? When there is no constant term, what does that simply? What does that What does it signify? It simply signifies that this line is passing through origin. Because y-intercept is 0, which means the line has to pass through origin, making an angle of 60 degree. Okay? Great. I'm sure everyone would have solved example number 10. That was pretty straightforward and I don't think there is anything to be explained here. Right? Great. Now, let's say there is a point, this point, x1, y1, and the equation of this line is ax plus by plus c is equal to 0. If I want to find the distance of this line, ax plus by plus c is equal to 0 from x1, y1, this distance would be given by, instead of x, I would substitute x1, instead of y, I would substitute y1 plus c upon under root of a square plus b square. Clear, everyone? Okay. Now, instead of point in a line, what if two lines are given? a1x plus b2y, a1x plus b1y plus c1 is equal to 0. And the another line which is parallel to the first line, a2x plus b2y plus c2 is equal to 0, and if I want to find the distance d, okay, then what should be done? Tell me, how do you apply this? So the first of all, what you have to do is try to make this a1 and a2 equal. Okay, try to make this a1 and a2 equal. Let's say by multiplying this, we make this a and we make this b, and here also we make this a and we make this b. Okay, and let this be c1 and let this be c2. Then the distance d will be given by c1 minus c2 upon under root of a square plus b square. Okay. And again, this would be a mod. Like in the previous question, I think in the previous formula, I forgot to put the mod over there. The entire equation would be in the mod because the distance will always be positive. Distance cannot be negative. Now, let us take an example. What I meant when I change a1, a2, and b1, b2. So, for example, let's take the line as 2x plus 3y plus 5 is equal to 0 as one line. And let's say the another line is 4x plus 6y plus 15 is equal to 0. Now, the slope of this line is minus 2 by 3 And the slope of this line is minus 4 by 6. That's minus 2 by 3. The slopes are still equal, which means the lines are parallel, which means I can still find the distance. But before that, you'll have to make this as 2, 3, so that both becomes equal, or you make both of them as 4 and 6. So I would try to make both of them 4 and 6. Okay, so this equation would now become 4x plus 6y plus 10 is equal to 0. So the distance between these two lines, 1 and 2, c1 minus c2, that is 15 minus 10 upon under root of 4 square plus 6 square. So 16 plus 64, the square root of this. So this is 5 upon root 80. Correct? And root 80, you can further simplify this. 80 is 16 5s are, I can take 4 common and I can write this as root 5. Correct? Now I can further simplify and I can write this as root 5 by 4. So this is the answer in the simplest form. The distance between these two lines will be root 5 by 4. So I am sure you understood what I did here when I changed A1, A2 and B1, B2. The objective was to make this A1, A2 and B1, B2 same, so that I can use A square and B square. Otherwise there is a confusion whether to use A1, B1 or to use A2, B2. So it's better to make A1 and B1, A1, B1 equal to A2, B2. Clear everyone? Great. Just take this question, copy down in a minute. We'll move ahead with the equation of a circle. Okay, so let's move ahead with the equation of a circle. Okay. X square plus y square is equal to r square. This circle is passing through origin with the radius r. It is passing through 0, 0. Okay. Now what if the circle is not passing through origin? Okay. Let's see if a circle this is the origin, which is h comma k. Okay. Now in this case, this origin 0, 0 has been shifted to h comma k. Correct. So what will we do is, instead of x, we will say it is x minus h because it has shifted to h. Okay. Plus y minus k, x minus h the whole square plus y minus k the whole square is equal to r square. So this is how you will write the area, the formula for equation of a circle if it is not passing through origin. Let us see what happens when we try to expand this. Let me first erase this. Let us expand this first. So what will I get? I'll get x square, I'll get y square minus 2hx. I'll have minus 2ky plus x square plus k square is equal to r square. Right? Let me bring r square on left hand side. This becomes 0. So this has some variable. These are entire constant. So let us keep this as c. So the equation becomes x square plus y square minus 2hx minus 2ky plus c is equal to 0. So what if the equation is given like this? If equation is given like this, in that case, your center, the center of a circle would be I know the center of circle was h and k. So here it would be coefficient of x upon minus 2. So if I say minus 2h upon minus 2, that gives me h, comma, coefficient of y upon minus 2. That's minus 2k upon minus 2, that gives me again k back. Great. Now if I want to find the radius, I know that h square plus k square minus r square is equal to c. That is what we have replaced here. Great. So what I had written here was, I had written h square plus k square minus r square is equal to c. So what will be r square now? It would be h square plus k square minus c, right? So from this, if I want to find out what is the radius, it will be under root of h square plus k square minus c. So it will be h square plus k square minus c in the under root of entire thing. That would be the radius of a circle for this equation. If this equation is given to me as area of as equation of a circle, then this is how I can find the center and the radius of a circle. I would want you to copy down this. Come to page number probably on yeah, we are on page number 6, equation of a circle. So this equation is already given. I would want you to copy down this part. Just take down this. Okay. Let's solve two questions before we end this topic. So now, what if I give you equation? There is a line 2x plus 3y plus 6 is equal to 0. Okay. Now, I want to find out that a point minus 2 comma 3 passes through a line this and it is perpendicular to this line. So what would be the equation of a line which passes through minus 2 comma 3 and it is perpendicular to this line? Giving you 2 minutes to solve this question. Just try. So let's see how can we solve this question. Let us say this 2x plus 3y plus 6 is equal to 0 is this line, and let's say minus 2 comma 3 is here. And we know that I want to find an equation of a line which is passing through minus 2 comma 3 and it is perpendicular to this. To find the equation of this line, I have 1 point. If I get one more point, I can apply 2-point form. Or if I can't get one more point, if I can somehow find the slope of this line, I can still get the equation of a line using the slope point form. So, if the two lines are perpendicular, the slope of this line into slope of this line is product is minus 1. So, what is slope of this line? Here, m1, the slope is nothing but as minus 2 by 3. The slope of this line m2, can I say it will be 3 by 2? It's negative reciprocal, right? So that becomes 3 by 2. So now I have point and I have a slope. So what I can do is I can straight away apply. It's y minus 3 is equal to x minus of minus 2, it is 2. Correct? So if I simplify the 2 multiply here, that's 2y minus 6 is equal to 3x plus 6. So I have 3x minus 2y is equal to I have 3x minus 2y plus 12 is equal to 0. So this would be the equation of a line which is passing through minus 2 comma 3 and it is perpendicular to this line. Let's take one more example. Let's say the triangle whose coordinates are 2 comma 3 minus 3 comma 1 and I have here 7 comma 5. So I want to find out equation of a line that is passing through A. So let's say I want to find an equation of a median starting from A, and I also want to find out the length of that median. Again 2 minutes, solve. Okay, so we want to find an equation of a line which is a median, correct? So to solve this question, you should know a property that median bisect the opposite side. So let's say D is a midpoint of BC. Okay, so if I want to find out the coordinate of D, so that is 7. How will I find the coordinate? Will I say 7 minus 3? What is 7 minus 3? That's 4. And what is 4 divided by 2? That's 2. Correct? And 5 plus 1, that is 6. 6 divided by 2 is 3. So now I know that it is passing. Okay, I think I gave you some. Okay, so let's say this is 2 comma 5. This is 3 comma 5. Great, because unfortunately I given a random number and the A and D were coming out of the same point. Great. So once I know that A is 3, 5 and B is 2, 3, what I can do here is I can use 2-point form and get the equation of a line. Great. Also, now if I want to find the distance AD, what I can do here is I can apply distance formula. I know 2 points x1, y1 and x2, y2. I can apply distance formula. So what will be the distance here? That will be 3 minus 2, 1 square is 1 and 5 minus 3 is 2, 2 square is 4. So this will be root 5 will be the distance of a median. Correct? Great. So this will be the distance, and if I want to find out the equation, so let's find out the equation, that is y minus 5 is equal to 5 minus 3 upon 3 minus 2 into x minus 3. Correct? So this is y minus 5 is equal to 2x minus 6. So now I have 2x minus y minus 1 is equal to 0. This will be the equation of a line. I'll repeat it. So it is y minus y1 into, so the slope, it is this minus this upon this minus this, right? Into x minus x1. Correct? So this is 2 upon 1, and I open this and you simplify, you get this. Clear everyone with this? Okay. Now let's say equation of line is 2x plus 3y is equal to 6. If I want to plot this line, how can I plot this? So what you can do is put x is equal to 0. What will be y equal to? Y equal to 2. So it is passing through, y is equal to 2. Now you put y is equal to 0, x is equal to 3. So this is the line that I have. So if you want to plot a line, this is how you can plot a line. Now let the number be difficult. I mean, it doesn't matter. Let we have a bigger number. Let's say I have 7x plus 13y is equal to 55. Okay, you will not get an integral values. I have purposely given it. So okay, let's make one of the number to be negative as well. Let's say it's like this. Okay, now. So, hide this, your y will be minus of 55 by 13, correct? So, that will be, what is 55 by 13, slightly more than 4? So, this is minus 1, minus 2, minus 3, minus 4, it will be somewhere here. So, this point is minus 55 by 13, comma 0, correct? Everyone? Great. Now, if I hide this, so x coordinate is 55 divided by 7. So that is approximately very close to 8. 56 divided by 7. So this is, let's say 1, and let's say here I have 8. This is 8. So this point will be 55 comma 7. 55 divided by 7 comma 0. So now the equation of a line would be like this. This is how you can draw equation of any line within 30 seconds. Clear with this, everyone? Great. So I think with this we end this chapter, coordinate geometry. Now what I would expect is that the exercise 1 and 2 of coordinate geometry, solve it today itself, so that in next couple of days what we can do is we can solve your doubts, whether it is online or it is by some other mean. Will help you out solving your doubts. But it is very important, after you have gone through this video, okay, go through the concept first, okay, solve the questions once again, solve everything once again that we have done in this video, and then solve exercise 1 and 2. I am sure you will be able to solve majority of the question. Thank you very much. We end this session here itself. Thank you guys.